In addition, we are not alone. All the mobile operators are facing great friendly or not so friendly competition from the new generation service providers. A large part of them are usually called OTTs. In this country, you have Google, you have Facebook. In China, we have Tencent, Baidu, Alibaba. They also are among the top 10 global internet giants. Actually, we appreciate the competition and challenge posed to us by them because that make us learn that we have to do a better job. Particularly, we have to be much more agile in the future to learn from them. Well, as I said that we actually started thinking about 5G about 3 years ago, assuming that it's gonna take a while before anybody else in the world would mention the word 5G. But the rest is history. The whole world has been talking about 5G now for 2 years. And in the 2 years, I would say most of the accomplishments from various forums of 5G has been on the vision. And the vision is really basically everything under the sun needs to be connected and covered by this new infrastructure. I used to joke that I think in our vision, or the global vision, it seems that the only thing that's left not connected is the breathing function. Every function that we have to perform is somehow connected by the infrastructure. Okay, I think this morning at the panel, I already shared with you the beautifully said Chinese sentence, 信息随心智，万物触手机. I think there are a few of you in the audience can read those characters. And unfortunately, the English translation is not as beautiful, but more or less it gets the message across. And this actually was included in the white paper issued by IMT 2020 promotional group in China. And that particular work group was led actually by China Mobile. So in a way, it also represents what we think and we feel. And this was issued in May this year. More recently, on behalf of a future forum, which unlike IMT 2020 promotional group, that is restricted to only domestic mainland entities, contribution. The Future Forum is a global multinational forum where China Mobile also led the 5G SIG. And 2 weeks ago, on behalf of Future Forum, we issued their white paper, where in addition to the vision, some KPIs, we also covered some of the key technologies and key themes of what we believe 5G should be. And some of you have seen, I think all of you have seen the Venn diagram. And in the beginning of the past 3 years, I used to joke that 5G, maybe if instead of the van, it's gonna be a stretch limo, or a recreational vehicle or so, but actually it's much more interesting than that. So in the IMT 2020 promotion group white paper, there was a beautiful flower of 5G. Now in the Future Forum, it's more international and global, so together we came up with actually a superstar. That's a superstar with 3 pairs, 6 moons circling around the superstar on 3 orbits. One of the orbits are about the density. The other orbits were the data rate. And then finally, I think there is an orbit about the latency. As far as latency goes, I think the previous speaker had talked about 1 millisecond or 0.1 millisecond. I have to say that 1 millisecond has been a favorite number by many forums when they talk about 5G, but it was never clearly delineated whether it's end-to-end or over the air alone. Well, here we actually explicitly separate the two because we believe 1 millisecond over the air may be doable, even though it's quite challenging. But end-to-end, that doesn't seem to be a reasonable target because many things can happen when you go across the wide area network. So we deliberately separate the two. With the end-to-end, we have a tentative number, but I believe a lot of work needs to be done before we can really settle that. And as far as the data rate, in this particular forum, we had a consensus that certainly the peak data rate for the user needs to be at gigabits per second. But of course, there's a debate whether it's 1 gigabits or it's 10 gigabits, somewhere in that range. But you probably remember that 10 years ago, when ITU issued the 4G requirements, there was the 1 gigabits per second already. Okay, but we are not quite there yet. And then we thought it was very important to include a minimum user experience data rate. Here, we have chosen 100 megabits per second, which means anywhere, everywhere you are, you should experience such data rate. You probably also remember that since the 90s, since we got into 2G, we were already very excited and talking about every, remember? We're still, in a way, talking about the same thing, but we're doing a better job, hopefully. And of course, there is also the mobility. That's represented there by a shooting star next to it. Okay. I think this superstar 5G is quite entertaining and interesting. Now, remember the efficiency and agility. We feel that 5G or 5G era or any future evolution of 4G or future infrastructure has to address those two keywords, not just for China Mobile, but for everyone. So to address that, we choose green and soft to be the research theme for 5G from the beginning. Green and soft. Green, it means you have to be efficient, not only from the user terminal's point of view, but all the way end to end to the whole infrastructure. Soft means that you should be able to efficiently configure, reconfigure from not just the core network, but to the radio access network and to the air interface. Okay. So with the two themes, green and soft, we had polished slowly 5 of our technology pearls. Some of you might have heard of this term before, because we kind of like to liken the unknown 5G to be a beautiful pearl necklace instead of an elephant. Okay, in the beginning we were using elephant, trying to figure out the fan as the ear, or the whip as the tail, or as with the trunk, etc. But soon we felt that analogy of beautiful unknown design of pearl necklace would be much more attractive. So what we were doing is, at the time that we felt that we still have enough time to do a really solid work to find the proper pearl that may be able to get on that necklace. Okay, so the 5 pearls that we've been polishing represent rethinking lots of fundamentals in our field. The first one, rethinking our favorite person, Shannon. I'm sure nobody in this room would be unfamiliar with Chih-Lin, right? Chih-Lin guided us for over half a century, showed us the relationship of communication system capacity as a function of signal-noise ratio. And for the previous 4 generations, we all made good use of Chih-Lin's theory and improved spectral efficiency of our system generation by generation. This time around, we thought we should rethink Chih-Lin. If you just do a little bit of transformation of the Chih-Lin equation, you will see that instead of it being a relationship between capacity and signal-noise ratio, it could become a direct relationship between energy efficiency and the spectral efficiency. And better yet, in a real system, unlike what's shown in Chih-Lin's equation classic form, if you include the non-zero power consumption any real communication system must consume prior to transmitting the signal over the air, you will find that the relationship between energy efficiency and spectral efficiency is not a monotonic trade-off. Because classic Chih-Lin would show that if you want to improve your energy efficiency, you would have to sacrifice your spectral efficiency, which in a real system is not so. It's actually a going up curve and then coming down. There's a peak, of course. And you might be interested to know that our current system, from 2G to 3G to 4G, are still on the rising part, the operating point, meaning that there's still room to jointly improve both EE and SE. Doesn't have to be a trade-off. So for the future system, under this guideline, we should be able to find the optimum design at air interface level, at the submodule level, even at the network level, the way to co-design both EE and SE for joint optimization. And the second pearl, instead of our favorite person, Chih-Lin, there are 2 of Chih-Lin's colleagues. Their names are Rin and Yang. I'm not sure how many of you have heard of them. Can I see a show of hands? Yes? Okay, there's 1 person. So, see, that's, we have what, 50 people, 40 people? So, percentage is not very high. Well, the second pearl is rethink Rin and Yang. Mr. Rin and Mr. Yang were contemporaries of Mr. Chih-Lin. They were both researchers. I mean, all of them were researchers at AT&T Bell Labs Research at the same time. When Mr. Chih-Lin published his favorite classic paper, The Foundation of Information Theory and Communication Signal Processing, Mr. Rin and Mr. Yang published actually the original first proposal, also a paper, proposing the cellular system as we know, which basically says you have this cellular frequency use structure, and every base station is in charge of resource allocation, radio coverage, signal processing, mobility management, everything. Okay, base station by base station. And I think implicitly, from 1 to 2 to 3 to 4G, we have been designing the standards based on that concept. But we all know that traffic is not homogeneous, neither in time nor in space. So we have now HeadNet, we have now COMP, we also have had DSA for a long time, or DAS, sorry, DAS for a long time. we also had relay and other kind of patch job in our previous generation of networks. So this time around, we say, let's rethink yin and yang. So from day one, when we design the 5G, we should know we don't follow the classic approach. No more, quote, sales. Okay. Now, third pearl is rethink signaling and control. Why? Because from the lessons we learned from the current network, we did an analysis with the real traffic profile that's running on our 4G network, comparing the voice traffic versus traffic like QQ. Okay. And guess what we found out? Because we have connection set up, we have keep alive, we have mobility, all built in our signaling control. The data signaling ratio of these two types of traffic differs by 2 orders of magnitude. Yes. For voice, the DSR over the air is about 100, and it would change depending on the mobility. Whereas QQ, the DSR is less than 1. Even if you are stationary. When you start moving very quickly, that DSR drops to 0.2. That means 50 to 80% over the air resource that's used for QQ type of traffic is overhead. This is extremely inefficient. And the cause was, even though we have transformed our core network from circuit switch to packet switch to be as close to internet as we possibly can, somehow, over the air, the signaling has maintained its connection-oriented nature. So, that's the third rethink. We believe that we need to have a much more clever and dynamic combination of connection-oriented and connectionless signaling control mechanism built in for 5G. And at the minimum, this signaling control mechanism needs to be 1, application aware, service aware, 2, load aware. Okay? Of course, you can add other things, mobility aware, user aware as well, but at the minimum, you need to be application and load aware. The fourth one, rethink antenna, rethink base station. Basically, you probably have heard, not only as 4G evolution, 3D MIMO and the larger scale MIMO is being contemplated, but also for 5G, everyone is talking about the massive MIMO or LSAS, where we are talking about, instead of in the 4G, currently we have 8 antennas in TD system. We are talking about 128 antennas or 256 antennas. Some people even are talking about 1,000 antennas with corresponding number of RF transceiver chains. Okay. Now, mind you, if you are just building it at millimeter wave band, maybe that's okay. It's not such a big problem because the form factor is automatically shut down. But as we are still quite interested and have a great effort and focus on looking at a 5G design for below 6 gigahertz band, can you imagine what kind of monster it would look like? Where are we going to find a place to put it? So because of that, we say, okay, let's do it once and for all. Let's make the base station disappear, make it, quote, invisible. I'll show you what I mean by that later. If you haven't heard me talking about it, it's somewhere else. Okay, finally, actually, it's a very complicated pearl. I would say the others may be single color pearls, we're just polishing it. The fifth pearl, the rethink spectrum or rethink air interface design, is a multicolored pearl, and also it's not quite smooth yet. It's bulging and it's big, it's huge, and it's a continual growth, I believe, where actually we lumped different spectrum access technology, as well as new waveform design, new access, multiple access mechanism, etc., all in that giant pearl. And there, our current feeling is that what we will need is SDAI, software-defined air interface, so that it can dress for the occasion. Since 5G really wants to face many different challenges in very diverse environment, we need an air interface that is much more adaptive, and but it would have to make sense to be put together in a common platform. Okay, so these are the 5 pearls, and one of the, actually, there was a special issue on 5G this year in IEEE Communication Magazine in February, which is, I think, among now probably there are 50 different special issues being planned by different publications for 5G. This is the first special issue on 5G published by IEEE. And our paper talking about the green and soft and these pearls were actually highlighted there as actually the first paper. We're very pleased with that, and you can take a look if you're interested. Now, with the pearls, with the KPIs we're talking about, this is kind of an array of the technologies that we believe would be important to consider. Maybe not all of them will make it eventually, but so far, they all seem to have a place in the future design. Okay. I think I'm not going to spend time because when I got up here, I think my 20 minutes was already left with less than 10, right? Okay. So this is the family of, I think, the most important opportunities in the transmission side, and this is on the network side. And in addition, there are some special end-to-end considerations we should include in the design. Now, LFP and SDN has been talked about so much, if not for the past 3 years, at least for the past almost 2 years, as important element for 5G. But there's something interesting, I have to say, because we have been working on C-RAN for a long time. Even before we started the 5G program, we considered C-RAN as a revolutionary evolution for the RAN. That means not only for the future 5G design, it must be an essential element, but also for current system, be it 2G, 3G, or 4G evolution,